I'm Dave Lacy. I work here in Villanova. Primary responsibility being the digital library side of things, which we started recently using VuFind as the front end for. When I say recently, I mean a couple years ago. So the point of this talk is we'll start by describing how we model our digital objects and how we integrate those objects within Solr specifically. And then Chris will take over and discuss some of the aspects of the front end which communicates with the Fedora Repository. And then we'll close with what we plan to introduce to our digital library within the next couple months based on some of the newer aspects of VuFind 2. So there's our URL. And when we say we have a digital library, what we mean is primarily we have lots and lots and lots of scanned items. They could be books, maps, theses, you name it. Scrapbooks. We have a scanning lab upstairs that's running as often as we can have it through the use of student labor. And in the past, 6 or 7 years, we've amassed about maybe 19,000 items, which are about 250,000 scanned items. So that's not a bad chunk of work in a few years. And last winter, we migrated all of this content to a Fedora Commons repository. If you're not familiar with what that is, it's actually kind of hard to describe, but it's essentially it's a software-based file system manager that kind of combines metadata and data objects and relates them together to each other through RDF ontologies. And what I mean that is we have a basic model of object that could exist in the repository. We broke it down into essentially two items. We have things that are collections and we have things that are data. And we extended that a little bit more to represent the different kinds of collections and the different kinds of data that can exist. So we have different kinds of collections. We have folders, resources, and lists. Resources are things as they exist in the real world, like a book or a map. That's what we mean by a resource. Lists organize, or another collection that kind of organizes data on a smaller level. And then the data themselves can be anything that you want to ingest in it, images, videos, audio, files, things like that. And all of these objects relate to each other using RDF ontologies, in which case, I am a member of this object, which is a member of that object. So here's a standard kind of hierarchy of what one resource might look like, or a collection. So we have a folder of dime novels, and in that folder you'll have a resource called Bride of the Tomb, and then that resource will have members that exist as data objects, which are in reality the scanned page, which will be a complicated object of the master file, several derivatives, an OCR file, and so forth. The hierarchy can get a little bit more complicated, for better or for worse. So we have our Buffalo Bill folder of dime novels that exists in two different collections itself. It's a member of a list of series, and it's a member of the fiction. And it was our goal within VuFind to take this hierarchy and be able to, I guess, in essence, flatten it into Solr, but still be able to traverse it like it were a real hierarchy. And when we first rolled this out, we decided to incorporate two different kinds of objects within the Solr index. We're going to resource our folders, and we're going to index our resources, our books, the core metadata. And based on the effort of Owen O'Carrigan in Ireland, was it the National Library of Ireland? He wrote a VuFind extension that, through the incorporation of a few additional fields in your schema, you can represent this hierarchy by recording parent and child relationship IDs within the Solr schema. So that facilitates the browsing of the digital library. You can traverse these folder directories and whatnot. As far as getting data into Fedora, right now we are using sort of like a harvest method where we determine newly modified objects and then ingest them nightly. So now I'll break out and just show you briefly what this all looks like. The live demo. Okay, so here's all of our root collections. We'll do the dime novels because that's getting a lot of play right now, or traction, if you will. So here's the core folder. So this is the root level object, and you can see all of its member objects. These are all folders. So if we go into the fiction folder, we're now displaying all of the members of this particular folder and so forth, and you can continue to drill down. You can also see, I keep clicking that guy. You can do fancy things like viewing the object, how it exists within the whole tree of the digital library. And again, this is work done by Owen O'Carrigan. Resources can have multiple collections or be in multiple places. So see, this item exists in two places at once, and that's based on that. The RDF ontologies mentioned earlier, it's a member of multiple places, and it's indexed into Solr by including both of its parents, and that's how we can determine, you know, its multiple membership. Oh, and of course we can search. This is VuFind, right? So if we search for dime, we can then bring up the list. I mentioned we're indexing both folders and resources. So the first result that you get is a folder, and you get more folders. But now you're starting to see some resources that include the word dime in their title. So that's how that gets married together. And that's how it exists now. I'm going to let Chris talk a little bit about the front end, or the item viewer incorporation with Fedora, and then I'll come back and talk about where we're going shortly. But Chris?
Hello. I'm Chris Hallberg, resident template master. I'm talking about the front end. The front end, as you know, is everything above Fedora. So when we talk about the front end, it includes the VuFind backend. So I'm the creator of not only the very, very front end, the actual template and CSS of the digital library, but also the VuDL controller and soon to be VuDL module come out. So when we're backstage in the Fedora, as I said, each resource, let's say that this is Bride of the Tomb. It's a very popular one around the office. You have different things. So on the right, all those lines represent the metadata. On the left, we have, let's say, an image of the cover of the book, which all its different variations. But then maybe there's an ebook version, and then there's the podcast version, which is also famous around the library. And this is pulling from Fedora, but because we want to keep it, we don't want the calls to make more calls. We also cache a lot of this to keep it simple. So you get a front end. This is kind of a wireframe version of what you just saw briefly of the item view, which I'll show towards the end. So we show all the items that are in the resource on the left side, like a scrollable pane. All the metadata is put into a collapsible accordion that goes back and forth here. And we put all the rest of the data into tabs along the top. So this is the medium view. This is like the large view if you have a higher resolution version of the picture. If you have a really high resolution version, you might get a zoom view, which is a custom built JavaScript library that allows called Zoomy that we made that allows you to zoom in and out and turn an image. And then of course you have the download page with more metadata like the OCR and the really descriptive technical information at the bottom. So what happens is when you want to switch pages, this is one of the few parts of VuFind as is right now that is completely JavaScript dependent. When you click on an item, the link actually includes all of its all of the data necessary to display it. So it passes all the data to the back end, to the VuDL controller, which then takes its representation, which is all our Fedora data already ingested in, and it renders the view of just the right side of the screen, just the tabs and just the content of the tabs. And the technical data get returned as its own, as a HTML response, which then replaces the right half of the screen. So the left half doesn't change, and we're using Ajax to swap the right half out. This is really important because different file types, we're trying to keep it open to as many different file types as we can, pictures, audio data, video data, downloadable data. Each get their own view. So by creating different templates or different views, you can handle possibly every single type of data that has an interesting way to display on the web. So right now we're looking at the ebook version, which only has a download because there wasn't really a friendly way to display it in a web page, even with some JavaScript libraries. But if you had something like if you want to play the podcast, our templates on the website actually allow you, that we actually use an HTML5 player that you can actually play in the browser. And each of these can be added and removed and customized, not only on the template level, but in the configurations you can change which types of files used which different views. That way, if you have MP3, MP4, MP5, that's not a file type. You can have a meaningful display as opposed to just a download for everything. So our pages get the medium, large, zoom, and download treatment. Our audio get a download and play. It's all different based on each thing. So a quick look at how that looks on this end. So actually, so here it is in action. You see that this is actually the podcast version. It's sorted into our search results. That happens sometimes. But you can see we have, these are all the different channels, all the different data objects that are underneath this resource object in the Fedora model. So we have the DC, which is the just like technical data, the thumbnail, which is what displays on the left side over here, the master, which is the actual audio file, which is downloadable. But we also ingest our own MP3 version, which allows it to be played online. So if I clicked it and the speakers aren't hooked up, so everyone on the web broadcast would get treated to a lovely podcast narrated by myself, Laura, and Damien. Then the OGG, which isn't a video format, so just labeled wrong, but the OGG also is an audio format. But if we looked at the actual scanned dime novel version, which isn't here, there it is. You can see that it's swapping out the information. Because it's the same type of data, it only swaps the content. But if we were to swap to, let's say, the PDF version, it would actually change the entire right half of the screen to become something much more useful. And that's more or less how the front end of the VuDL system works. So where we go from here is back to Dave. Thanks again.
Front end, we did that. Okay. So we obviously want to keep moving forward and improving upon this system as we go along, and the first the way to do that is to find the limitations. Okay. So I mentioned earlier we were only ingesting folders and resources, and we have tons and tons and tons and tons of OCR data, which right now we are stuffing into the parent resource. So when you match a hit on, Queenie or Bride of the Tomb, it may find these words within a book, point you to that resource, and then you're on your own to sift through, several hundred pages to find these words. That's a problem. Browsing, doing the flattened hierarchy has proved to be challenging, especially with the way that we kind of sort or apply a sequence to the page objects. We found in Solr you can't sort on a multi-valued field. So if you're an object with multiple parents, we can't sort on your sequence because you'll have two of them. I'm in these two different folders. I'm in position 10 in one and 20 in another. So our solution to that was just pick one and ingest it. And in one collection it'll look great, in the other it'll be completely out of whack because you'll be at position 20 and you're supposed to be in position 10. So that's a problem. Our ingest process is also less than efficient. We're doing kind of like a harvest system. Overnight we poll for anything that's changed and then ingest those. So these are some things that we can improve upon, and we have. Here's the plan. We're going to start indexing everything, including the data objects. This solves a couple problems. One, it eliminates the need for a nightly ingest because we can just ingest automatically through a Fedora plugin called gsearch. And what this is a Solr plugin for Fedora that listens for changes in the repository and immediately ingests them into your Solr core. So anytime you modify an object in the repository, it automatically gets updated in your Solr, which is great. So now that we have our data objects in there, we don't need to stuff all the OCR into the parent resource either. And the way we handle this is through field collapsing within Solr. So we put all the data in. I'll go over that in the next slide, I think. So I'll explain how that works then. And then I came up with a way to handle the multiple parent sequence issue by just implementing a dynamic field that references your parent ID and then displays what your position is in that collection based on what your parent's ID is. So a little bit about field collapsing. The way this works is in Solr, it works similar to SQL grouping. So you can group by your parent ID. So as far as the data objects go, the parent ID would be the resource. And for everything else, the folders and the collections, your parent group would be yourself, because you don't want to collapse on the folder, then you wouldn't get any resource records. And the way this gets implemented is through what Damien talked about earlier today with a custom search module. And it was pretty simple. When we put this together over the summer, we were really surprised at how fast we were able to accomplish it just through a minimal amount of lines of code. So we set up a custom search and just added a few parameters at the bottom to automatically add the field collapsing parameters to the bag, and then you plug it into your main config, and it actually just worked almost immediately with a couple of modifications that needed to happen to the front end, because the group results get returned from Solr a little bit differently. It returns the topmost tree, or the groups that match the IDs that you're collapsing on. So if you match an image, the grouped ID would be a resource, but if you matched the resource title, the returned group would be that resource itself. So we'd have to modify the front end to handle this different response. Demo. That was a note to myself. Not this one. They all look the same. Okay. So now we'll go back to our original query of dime, and again we'll see our folder containing the dime novel. We'll see a resource. And then, hey, look at this. We started matching some pages. And if you click on one of these pages, it'll bring the page that you matched already up in the displayer, or in the item view. You can see some really... The worse your query, the more dramatic the results. So here we can match the word him on all of the OCR data within our collections, and you can go to the page that references it.
Extra credit for getting a match on how to get married, although a woman.
Well, yeah, again, anyone familiar with the dirty OCR process knows that that's probably not going to happen. If you look at a lot of our OCR, a lot of it is garbage. It's a tricky art, but it is good enough for this kind of thing. You don't want to really read it, but as far as finding information on certain pages in a 1,000-page book, it could come in handy.
So it has a little marker that shows exactly where the word is?
No, that's always something.
Page.
Pardon?
That's just a tear in the page.
Yeah, that was not it. There are systems OCR markup. I think it's called HOCR, where it gives you the OCR and it's marked up with the coordinates of where it found the character on the page. We're not currently doing anything with that right now. We're just taking raw, straight text. But if you did employ something like that, you could then take the coordinates of that character and kind of piece it together and find it and highlight it on the page, which would be neat. So again, we plan on rolling that out to the public sometime this winter. There's a little cleanup that needs to happen to our repository to make it happen, but most of the heavy lifting on the front end is done and working. I want to thank Damien, of course, Mr. VuFind, Owen O'Carrigan in Ireland, who did the hierarchical browse. Pretty neat. We just pushed the Fedoraized version of our admin to GitHub. If anyone is familiar with Fedora and want to play with that, feel free and let me know what you think. Again, that's it. Thank you. Any questions?